Hello there and welcome back to Max World again. In previous video we learnt about the distance formula, and in today's lecture we will try to understand and solve few sums which are based on distance formula again. Here we go with the third sum on the board, which is from exercise 5.1. The question says we need to find such a point which is present on x-axis and equidistant from point A and B, which is given in the question. Okay. Very first, for the better understanding of the sum, let's have some diagrammatic representation. As the point is present on x-axis, so here is the x-axis point. Let that point be C, the way you're looking, and point A and B, logically they are present in such a manner the way it is shown in the screen. Okay. Now, as point C is present on x-axis, so keep it in mind, its y coordinate must be or has to be 0. Okay. So in all, coordinates of C are nothing but x, that we need to find, and 0, y coordinate is 0. Okay, so x and 0 are the coordinate of that required point. One more information is given in the question, that is point C is equidistant from A and B. That means if we join CA and CB, their length or the distance must be equal, isn't it right? So we can say distance CA must be equal to distance BC or CB, because point C is equidistant from point A and B. Okay, so once we apply distance formula to AC and BC, then ultimately by carrying out few calculation and few shifting, we'll get the value of x. So here we go with the sum on the board. Answer part, first part is already explained to you. So just begin the sum by applying distance formula to it. Okay, the moment you apply distance formula, keep it in mind, purposely each time in the formula I have mentioned coordinate of C in the first place. Okay, that will help you to solve the sum in easier manner. Now insert the values. In this step we are gonna remove the square root from both the side by squaring the terms. Okay, so that means by squaring both the side we can remove that root. The root is cancelled. Next step, now observe the values. We are left with x plus 3 the whole square plus negative 4 the whole square, that, and on the other side we have x minus 1 the whole square plus 4 square. Okay, so negative 4 square and 4 square both will result in 16, the way you are looking on the screen. Okay, and as we are given with the bracket, that is x plus 3 the whole square, that means we have to utilize expansion formula, that is a plus b the whole square. What is that formula? Yes, a square plus 2ab plus b square. Okay, the moment you apply that formula for x plus 3 the whole square, we get the answer x square plus 6x plus 9. Yep, and plus 16 we got after squaring 4. On the other side we get x square minus 2x, yes, because between we have x minus 1, the minus sign is there, that's why a square minus 2ab we have to use. Okay, so what we have over here, x square minus 2x plus 1 plus 16. Now on both the side, if you observe, there are few like terms, right, with the same sign, like x square and x square, so we can cancel or strike out those numbers. So x square you can strike out, okay, and 16 also, yes, because 16 is in positive on both the sides, so 16 is also removed. So what are we left with? We are left with, after striking them out or cancelling them out, 6x plus 9 and negative 2x plus 1. Okay, now these are nothing but the linear terms, right? Always keep it in mind, to solve the linear equations we have to shift or we have to move numbers with letter on one side, numbers without letter on other side. Okay, so what we have, that negative 2x will be shifted or moved to the other side towards the 6x. So what we get, 6x plus 2x, and from 6x side 9 will be shifted to the other side, that is towards the 1. So what we get, plus 1 minus 9. So in short we have 6x plus 2x equals to plus 1 minus 9. The moment you carry out the operation mentioned there, we get 8x equal to negative 8. Integers rule, bigger number sign, don't forget that part. After that while shifting, after shifting that 8 towards the other side of the equality, we get x equals to negative 8 divided by 8, and bingo, that's what our answer is. X equals to negative 1. And in short, as a final answer, we can say coordinate of C are nothing but -1, 0. Why 0? Because it's a y coordinate present, because C is present on x-axis. So in short, the required coordinates of the point are nothing but -1 and 0. Here we move with the fourth sum on the board. The question is, 3 points are given to us along with their coordinates P, Q, R, and we need to decide or check whether these points are the vertices of right angle triangle or not. Okay, again same thing, as points and their coordinates are given, we will proceed further with the distance formula. Why distance formula? Because to prove whether these points are going to make a right angle triangle or not, we are going to take help of Pythagoras theorem. Yes, right angle triangle, the god of geometry, Pythagoras. What does that formula states? Hypotenuse square is equal to side 1 square plus side 2 square. That hypotenuse is nothing but the longest side. So what are we going to do? We will find the distance of all these 3 sides. Okay, among them we will choose the longest side first and we'll make a square of it. Then we will find the sum of square of remaining 2 sides. Okay, and if that sum is exactly equal to the square of longer side, okay, then these sides are going to make right angle triangle, otherwise they are not. So here we go with our action plan. The first step, we have to find the distances by distance formula. So PQ is nothing but the way you are looking on the board. The values are put inside it. After carrying out the proper operation, we get under root -4 the whole square plus 0 square. Yes, 0, because 2 coordinates of P and Q are same, right? After that, by making 4 square, that is -4 square, that results in positive 16, and after taking square root of it, we get the answer 4 again. Okay, so number it 1. Now let's find the distance QR again by applying distance formula. The moment you apply the numbers or substitute the number in it, okay, what do we get? We get under root 0 square plus -5 the whole square after carrying out the operations. Okay, -5 the whole square, it will result in 25 under root. Okay, the moment you take out square root, again we are left with 5. Number it 2. Now we have to find side PR again by using distance formula. Input the values properly. After carrying out the operation, we get -4 the whole square plus -5 the whole square. After taking the square, we get the numbers in positive, that is under root 16 plus 25, and that results in square root of 41. And now check 1, 2, 3. What do you think? Which is the longer side by those values? Yes, PR is the longer value, because under root 41, under root 25, see, normal only 5 means under root 25, only 4 means under root 16. Now compare under root 16 or then root 25 and root 41. Of course root 41 is the longer one, right? That is why PR is the longer side. So we got the first step of our action plan. Okay, so we have found the longer side, so make a square of it. Longer side square is equal to PR square, and that gives the answer under root 41 the whole square. The way I told you in the previous lecture, square root of a square is nothing but a. Yes, square root of a square is equal to a. In the similar way, square root of 41 square is nothing but the 41. Yes, the answer is 41. So number it 4. Okay, now next step, after finding PR as a longer side, we are left with 2 more sides, right? So we have to do the squaring and then sum of those 2 sides. So here sum of square of remaining 2 sides, nothing but PQ square plus QR square, that gives us 4 square plus 5 square, 16 plus 25, and that results in 41. Isn't it right? Yes. So we can say, yes, number 5, we can say by 4 and 5, PR square is equal to PQ square plus QR square, and by converse of Pythagoras theorem, now I can state that These points P, Q and R are nothing but the vertices of right angle triangle, because we found longer side square is equal to sum of square of remaining two sides. Go with the fifth sum on the board. In the question, we are given with 4 points P, Q, R, S along with their coordinates, and I need to decide whether these points are the vertices of parallelogram or not. Okay. For the better understanding of the question, let's consider this parallelogram diagram first of all and name it PQRS in clockwise direction. Okay. Now there's one property of parallelogram. What the property? Opposite sides of parallelogram are equal in length. So if I'm able to prove PQ equal to SR and PS equal to QR or RQ, then only then I can say that this quadrilateral is a parallelogram. Okay. But how will we find the length of this side? Yes, by distance formula. By utilizing distance formula, we are going to find all these four sides, and if the distance of opposite sides among them is equal, only then we will say PQRS is making a parallelogram. So once, I hope the action plan is clear to you. So here we go with the distance formula on the board. We will find the value of PQ by distance formula. After substituting the values in a formula in a proper way, that is the first step. Okay, carry out the operation, you get negative 5 the square plus negative 5 the square again, right? That results in under root 50, right? Because 5 square 25, again 5 square 25, 25 is 25, 50. Number it 1. Now let's find length of QR. The moment you, again same distance formula, substitute the value in it, carry out the first step of the operation, then you get 4 square negative 1, yes, negative 4 square plus 4 square, and that results in under root 32. How? 4 square is 16, again 4 square is 16, 16 plus 16, 32. Number it as 2. Let's find RS now. For the RS, again use distance formula. The moment you carry out the first step of the operation, we get the answer 5 square plus 5 square, correct, in under root, of course. Carry out the square, 5 square is 25, so 25 plus 25, that results in 50, and as a result we get answer under root 50, number it 3. And the moment you carry out PS also, you will get the value under root 32, the way you are looking on the screen. Now observe these values. If you observe first and third, it is equal in measure, right? Then observe second and fourth, again it is equal in measure, right? So by 1 and 3 I can say PQ equal to RS, right? By 2 and 4 I can say QR equal to PS, and bingo, these are the nothing but opposite sides of the parallelogram that we consider, and as opposite sides are equal in length, we can say PQRS is a parallelogram. And sum on the board, and sixth sum is nothing but same as that of fifth one. In the fifth sum we showed those vertices are of parallelogram, and in this sum we are going to show them are of rhombus. That means procedure will be same. By distance formula we are going to find the length of side, but just one change will be there. Let's see what that change is. Very first, here's the question on the board. We are given with the 4 point ABCD along with their coordinates, and I need to prove them whether they are going to make a rhombus or not, right? For the better understanding, here's a diagram on the board on your screen. ABCD naming is done, right, in a clockwise direction, don't forget that part. In a rhombus, according to their its property, all sides are equal in measure, right? Their length is equal, and to find that length we are going to utilize distance formula, right? If I am able to prove AB, BC, CD and DA are equal in length by finding their length using distance formula, then we can say those vertices are of rhombus, right? So here we go with the distance formula. On the board the value of AB is mentioned, right, as a first step. In the second step, after carrying out the operation, we get -3 the whole square plus -9 the whole square. After carrying out the square, what do we get? 3 square is 9, right? Square of 9 is 81. So 81 plus 9, we get 90, that is under root 90, number it 1, right? In the similar fashion, you find the value of BC. First step is shown on the screen. In the second step, after carrying out the operation, we get again negative 9 the whole square plus negative 3 the whole square. What do we get? The answer of it. Same one, 81 plus 9, that results in 90 again. Wow, two sides are equal in measure already. The moment you carry out the value, the moment you put the value for the CD in the distance formula, we get again 3 square plus 9 square as the second step, the way you are looking on the screen. And after squaring and adding them, that results in again under root 90, number it as 3. Similarly, when you find the value of AD, again that results in 90. Now observe all these 4, all are root 90, isn't it? Right. So by 1, 2, 3, 4, I can say AB equal to BC equal to CD equal to AD, right? Since all sides are equal in measure, yes, we can say ABCD is a rhombus. Isn't it easy? Yes. So boys and girls, this is the 7th question on the board. This is a new pattern for you, because till now we have used distance formula just to find the length of the side, right, and prove certain diagrams. But in this question, distance is already given to us and we need to find a missing coordinate for the point given to us. Okay, so 2 points are given to me, point L and point M. Okay, for point L, coordinates are x and 7, and that x we need to find. For M, coordinates are 1 and 15, so name it as x1 y1 and x2 y2, the way you are looking on the screen. After that, the distance LM is given to me as 10. Okay, so we begin with the distance formula itself. So distance LM is equal to, of course, under root x2 minus x1 plus y2 minus y1 and whole square both the time. Now substitute the values. The moment you put the values inside it, you will come to know LM equals to 10. So substitute it in proper place. After that, if you check the values inside the root, you will come to know first bracket, that is 1 minus x square, cannot be calculated further. Okay, but the second bracket 15 minus 7, we can carry out the subtraction, right? The moment you carry out the subtraction, you will get the answer 8, right? But before that, we will get the rid of root sign which is on the RHS of the equation, right? How to get the rid of it? Of course, by doing squaring on both the side. The moment you do the squaring on both the side, that 10 will be written as 10 square, the way you are looking on the screen, right? And we get 1 minus x the whole square plus 8 the whole square. From where we got the 8? Of course, 50 minus 7. After that, for the bracket, we will operate it at last. Now see the two numbers, 10 square is 100, right? And 8 square is 64, the way you are looking on the screen. After this, shift that 64 towards the 100 so that you can carry out the operation very easily. What do we get the answer? 100 minus 64, correct? Because 64 was in positive sign or the addition on the RHS. After that, after carrying the subtraction, we get the value 36. Now what we are left with, 36 equals to 1 minus x the whole square. And now I can remove that square sign by finding square root on both the side, right? The moment you find square root on both the side, we get 6 on one side, 1 minus x on other side. But this time, as these are coordinates, okay, and we have taken out the square root, we have to give plus and minus both the sign for the 6. The way we know, it doesn't matter whether the number is positive or negative. After squaring it, we get the positive number, right? So 36 is in positive, it's a square. The moment we find the square root of it, we have to give plus and minus both the sign for that 6. Okay, after this, what we can do, we can split that 6 for plus sign and minus sign. Okay, what do we get? Minus 6 equals to 1 minus x, or plus 6 equals to 1 minus x. Now this time, if you observe the equation properly, x is in negative, right? So try to make it positive. How will you make the how will you make that x positive? Of course, shifting to the other side, correct? The moment you shift x on the other side, at the same time you shift that 6 on the LHS of the LHS on the RHS side. Okay, so what do we get? X equals to 1 plus 6, right? Or x equals to 1 minus 6. correct? Carry out the operation, what we are left with? X equal to 7 or x equal to minus 5, and bang, this is what we are searching for. So that x coordinate of L can be 7 also, can be minus 5 also, and this is what our answer is. Boys and girls, this is the last question of the exercise. The question says these points ABC are making equilateral triangle or not. This is pattern is usual, okay, the normal one. We will find the distances of all the sides AB, BC and AC using distance formula, but this time the coordinate is not the usual or the normal one. Check the coordinate of C, x coordinate particularly. We are given with 1 plus 2 root 3, and that makes it unusual. Okay, the moment we go ahead, I will explain you how to find the square of it also and how to operate on it also. So let's move on. Here is the distance formula for side AB, right? We have 1 minus 1 the whole square plus 2 minus 6 the whole square as a first step. After carrying out the operation, we get 0 square plus in bracket negative 4 the whole square. Negative 4 the whole square is nothing but under root 16, and after taking out the square root we get the answer 4 and number it as 1. Okay, now let's find the distance of side BC. The moment you substitute the value, we get 1 minus in bracket 1 plus 2 root 3 the bracket close and the bracket square. Then as a second, from the y coordinate we get 6 minus 4 the whole square. 6 minus 4 the whole square is the easier one to calculate, right? We get the answer 2 after subtraction, and then 2 square remains the 4, right? Now let's think and let's learn how to solve the first bracket. So here the first bracket, 1 minus in bracket 1 plus 2 root 3 the whole square, right? As the smaller bracket or the simpler bracket, outside it we have negative sign. So all the terms which are inside the bracket will have change in their sign, right? So what we get? 1 minus 1 minus 2 root 3, right? And the bracket close and the whole square. Now 1 minus 1 results in 0, right? We are left with only minus 2 root 3 the whole square, and that is why the answer is like this: under root minus 2 root 3 the whole square plus 2 the whole square. From where we got the 2, second 2, yes, 6 minus 4 2, and that is written over there. Now how to find the square of negative 2 root 3 the whole square, right? For the square we have to give that square for 2 also, for root 3 also. That results in 2 square 4, right? Doesn't matter whether negative sign is there or not, because after squaring it has to be in positive, right? So 2 square is 4 and root 3 square is 3. The way I told you, under root a square, answer is a, or root a the whole square, answer is a, vice versa. So we are left with 4 into 3, and that results in 12. So above in the square root, minus 2 root 3 the whole square results in 12. Beside that, 2 square, answer is 4. So 12 plus 4, answer is root 16, and that is why we have root 16 again, and after taking out square root of it we get the answer 4 and number it as 2. Now let's move on to find the side AC. The moment you check the bracket, you will come to know that the first step of the bracket, that is 1 minus under in bracket 1 plus 2 root 3 the whole square, is same as that of BC. So whatever the step we followed, the same step we have to follow over here, but no need to mention them, right? The moment you carry the operation ahead and solve it, you get the answer same pattern: negative 2 root 3 the whole square plus 2 the whole square. That results in root 16 as its answer, and after taking out the square root of 16 we get the answer 4 again and number it 3. So by checking 1 to 3 we come to know that every side, that is AB, BC and AC, is equal in length, right? And as all sides are equal in length, we can say these points are of equilateral triangle, and bang, we have proved it. So boys and girls, it's enough for today. In the next lecture we will try to solve 5.2 based on section formula, midpoint formula and the centroid formula. Till then, see ya, take care.